Hello everyone, this is Alexa Kam from the BioID Computation Booster. Today I will be presenting my project about geological formation simulations with Vellum fluid solver in Houdini. This is part of a collaborative project about seaweed farms. While Emily is developing a material from shells and algae, Tambi is focusing on the fabrication and environmental data simulations. My contribution is to generate forms inspired by nature which will respond to the environmental elements and that could be fabricated with our new material. For our project, we will need a support structure that hosts seaweed and other species while they grow. Corals building reefs with calcium carbonate is a microscale process. Therefore, I started looking at larger-scale ways of gaining ground from the sea, such as lava formations. And then I was captivated by the gogots and concretions as shapes generated by the interaction of minerals, water, and organic materials, or the geological formations sculpted by external forces such as wind and water erosions. A simple way to understand geological formations is through grain flows as a fluid mechanical phenomenon. All my work in Houdini is based on the use of a single tool, Vellum grain solver. Basically, Vellum solver needs an emitter, the particles that move according to the gravity force, and a collider. This fluid will change according to its viscosity from completely liquid to solid, the particles getting solidified with time, the surface tension from the cohesiveness of the molecules, among other constraints such as density. Just changing the viscosity constraints, the results can be as contrasting as these examples. But also, playing with viscosity and the speed of the particles, I was allowed to draw in 3D like an extruder and have full control of the material. Playing with fluid dynamics, I mixed 3 materials with different densities, so the least dense on the bottom will tend to go to the top and vice versa. In this case, I left the material as grains to visualize better the fluid exchange. Then, I made a variation of this, and instead of working with flat surfaces, I added volume and shape. In this case, the materials are visualized as fluids and not as grains. If we isolate the 3 materials, it is possible to see the physical behavior of each layer according to their position and density, and as a result, we have very interesting shapes. This approximates how geological formations were made, but in fast-motion simulations. Vellum solver allows to predict not only the interaction of materials with different properties, but also how multi-behavioral materials change along with time and how their properties can be visualized. If I turn off all the forces, even gravity, the tendency of the material is to expand limitless, and its behavior will only depend on its own characteristics. All these grains or fluids formations can also be affected by external forces. In this case, I used wind forces that affect the stress of the particles' cohesiveness. The application of Vellum solver fluids in my project will impact in the geometrical exploration, predicting the behavior of a viscous material that solidifies through time like lava or reefs. In this case, I simulated a viscous material that will be poured over the existing rocks to manipulate the surfaces for the benefit of the organism's growth. Then, this intervention will be affected by the erosion of the sea and the wind, and it will be a structure in constant change due to the colonization of the species.